Hello Internet. Today I am going to present a small tutorial on creating custom VPC in Amazon Web Services. Like you all know, VPC is a logical data center in Amazon Web Services. It consists of route tables, network access lists, subnets, security groups. But assume that you all know like what these basic concepts are, and we will directly proceed on to building our own custom VPC. Now, as a part of this tutorial, I am going to follow a workflow, the steps that I am going to follow to create my own custom VPC. At the end of this step, you will be able to form your own custom VPC in Amazon Web Services. So we will start on by creating our own custom VPC. So we will go on to the VPC section of our AWS cloud. Now one thing you can see here, we can create VPCs through two mediums. One is through VPC wizard, in which VPCs are directly configured by the AWS. You don't have to worry about network access control list, subnet, security groups. So but this won't give a full understanding of each and every component of the VPC that we are going to create. So what I am going to do is I am going to create my own custom VPC by joining individual components. So I'll go on to your VPC section. So like you can see, I'll create a VPC with CIDR block. I will use 10.0.0.0/16. CIDR block is nothing but classless interdomain routing address. It's a range of IP address which are permissible to within a subnet. Now I'll go and create my VPC. Give your VPC a name. I'll give just my VPC, and the CIDR block range that I will going to use is this one. You have to take care of one thing, like Amazon has given specific limitations on what range of CIDR blocks that you will going to use. So if you use another CIDR block range that differs from the range that Amazon has specified, then you will get an error. So I'll just use the CIDR block range that is specified by the Amazon. I will leave tenancy as a default. So I'll create my VPC. It will take some time to configure my VPC. So as you can see, my VPC is created. So another part of the VPC is to create a subnets. So in this tutorial we are going to create two subnets. One is public subnet, another one is private subnet. So we'll create our subnets now. And go to subnets. Now create your subnet. Give name. Give my public subnet. Take care that your VPC is chosen that you have created. Now for the availability zone, I am going to select US West 2A. Now you can choose any availability region as you want, and the IPv4 CIDR block range that I am going to use is 10.0.1.0/24, and so you can vary on this range unless and until you follow the AWS guidelines or follow the AWS guidelines for the range in which this CIDR block forms. So I'll create this public subnet. In a similar way, now we will create our private subnet. I have given it a name. It's in my VPC that I am defined. Now you can see I'm selecting the West 2B as the region for my private subnet, and the CIDR adlec box range is as this, and I'll create my block range. So whatever our databases that will lie, those will be part of our private subnet, and whatever the internet facing sites of our VPC that will lie in our public subnet. like you can see we have created both of these subnets. Now we'll follow our path. So now right now you can see like I have created my VPC, and I have created my subnets, but they don't have an internet access. So to give us the subnets internet access, we have to create an internet gateway. So I will now create an internet gateway. So I'll go to the internet gateways. I'll create an internet gateway. I'll give it a name. Just give my internet gateway. Okay, I'll create it. Now you can see like once this my internet gateway is created, it is not assigned to any particular VPC, and so I'll attach to the VPC that I have created. And also you have to take care that only you can assign one internet gateway per VPC. You can't assign more than one internet gateways. So I have created my internet gateway and assigned to my VPC. Now I have attached my internet gateway to the VPC. Now the thing was how to connect this VPC and internet gateway. We have to form some bridge in it. So by default, when I created a VPC, it created a default route table. I'll just rename it. So my main route table. So this main route table was created when I created my VPC. Now once you go to the routes, subnet association, you see like there aren't any subnet associations with it, but like whatever the subnets that you have created, and once you have assigned it to your VPC, those subnets would be a part of your main route table. So now what I will do is I will so if like our subnet is exposed to any risk, they will be directly able to access through the main route table. So to prevent this security measure, what we do is we create a new route table. So I'll go and create a new route table. I will name it my new route table, and see I will keep it a part of my VPC. Now it will create my new route table. Now in a new route table you can see there is no subnet associations. So what I will do, I will go here in my new route table, and I will give the access of internet gateway to it, so that whatever my public subnet that is associated with this new route table, that will be able to access the internet. So first we'll do that. Okay, I'll go to the subnet associations. I'll go to edit, and like you can see here, I am assigning this public subnet to this my new route table. So once I've done that, now we have to create a bridge to internet gateway so that we can access internet for this subnet. So I'll go here, and I will add a route saying allow all internet traffic to target my internet gateway, and I will save it. So what this has done is I have created a new route table for my public subnet, which has now route of internet through this internet gateway that we have created earlier. So I have created my route to internet in new internet table. Now I have also associated that subnet to public. Now you can see that for the subnets there isn't IP associated with my public subnet. So for the internet to identify my public subnet, it should be assigned with some IP. So I will assign an IP before at public IP for my public subnet. So this step, by going to the subnet actions and modify auto assign IP settings, we enable the IPv4 address for this particular subnets. What this will do is like whenever you launch an instance in this public subnet, those instances will be assigned IPs automatically, public IPs automatically. So we have enabled our public IP with subnet. Now the important part of our step is like to add EC2 instances to our public subnet. So for this we will go to our EC2 part, so that we will deploy two instances. First instance will be deployed in public subnet, second instance I will deploy in private subnet. So I'll go to launch instance. After going to launch instance, I am selecting Amazon Linux EMI. Then I will keep the T2 micro as my instance. And here is the main part. Here we have to change some of the configuration details. Here, like you can see, I have to select my VPC as my new VPC that I have created. I will select my public subnet, so that since I am launching this into my public subnet, this I am using it. And after that I am keep all the options aside. But how to check like whether this instance is up or not? So for that small we have small bootstrap script that we add in this advanced details. So what it does is like once our instance is configured, it will automatically install Apache web server in it, and after installing that Apache web server, it will create one HTML page. So that is just a sample page, so that going through that public IP we will be able to see that web page, so that we will get to know that this instance is working fine. So this is a small bash script. You just have to copy paste this script. This script I will provide in the description of the video. So what this does, like this installs Apache web server, then this updates, then it starts the web service, and it keeps the web server on for the next time when the instance is done. So this is a small web page that we are going to create in our var www.html and index.html file, and it's just a small text like I have kept like "you're awesome." You can keep any text that you like. So what I'll do is I will copy this script and I will paste it into my advanced details, so that this will automatically get triggered when my instance is up. One thing you have to note here, like since we have auto assigned or public IP earlier, you need not ever you are not required to make any changes in here. Since we have already done that, then we don't have to take care of this here. So this is done. Now I will go and I will add storage. I will keep 8 gigs as my default. Now another important thing is like whatever the instances that you are creating, make sure that you add the tags. It will be easier to know like what instances are up and what are not. So I will just give it a name, public instance. So for the I'll give it other name, public EC2. Okay, so for the security group we have to configure some security group. So we'll create a new security group, my new security group. So for this we will add SSH, we'll add HTTP, we'll add HTTPS, since these are basic ones, and I'm keeping it anywhere, so that this just for the tutorial. You can keep your own IP address in here. for the security purposes, but right now I'm going to keep it anywhere. Now we are going to give the description same as this one. Going to give the description as same. Launch and review. This will give a small warning, like since it is exposed to anywhere, so you need not worry about that. Then you have to launch instance. I already have my key pair generated, so you need not worry about that. If you don't have, you have to create a new pair. And if you are using Windows, then there are some steps that you have to follow to log in through PuTTY. But since I have this key pair already available, I won't be going to do this step. Now I'm going to launch my instance. So what we have done is like we have added our EC2 instance in our public subnet. Now we will add one EC2 instance in our private subnet. So for this what we'll do, we'll go to this launch instance, we'll select the Amazon AMI, we'll create the T2 micro to be in the free tier, and now the VPC will be my VPC that I have created. The subnet will be my private subnet. Earlier we chose public. We did not to do anything in here, even though if you add a bash script in here, it won't work since this instance don't have internet access. You will see it shortly that how it does not have internet access. So I'll go and add storage. I will keep it as default. I'll go and add tags. For the name, add it under name, and I will add it as I'll keep it as private EC2. I'll go and security group. So for the security group, we will create a new security group for SQL Server. So I'll just create one. My security group for MySQL. Okay, sorry for the long name. So what we will do, we'll add MySQL. Again, keep it. Now one thing is like first, and we have to keep all ICMP. So this ICMP is for so that we can able to ping this instance through our public instance. So for that we have kept this all ICMP, and this MySQL is for MySQL, and this is for SSH. So now what we will do here is, like you can see, I have launched my public instance with this subnet address, CIDR address. Now I'll copy that and I will keep the CIDR range as my public, so that whatever my public web server is, it will be allowed to access this private instance through all these types, since I have given the address ranges that are associated with my public instance, and no other traffic is allowed. So it is creating an implicit security layer, if you can see. So I'll go here and I will review and launch. Like you can see, it didn't give warning this time, since like we didn't this instance is not like directly internet facing. So I will launch my instance. I'll use my same key pair. So this is all done. We have created our internet gateways. We have assigned to this internet gateway to VPC. We have created route to in our public subnet to our internet gateways, and we have added to our EC2 instances. Now what we are going to do quickly is that we are going to SSH into our public instance. I will go and copy my public IP v4. I will go my putty. I have already configured my putty to work for the IP, and I have used the key that I have set earlier. Then once, like you can see now, I am in my putty. So other thing is like the IP address, public IPv4 address that we have, you can go here and you can test it out in here. Like once our instance is up, if everything is working fine, we should get the text that we use on bash script. So once our instance is created, it installed Apache web server, it created the web server, it assigned the public IP to it, and whatever the web page that HTML had, it is now being displayed in our public IP address. So from here, now what we will do is like we will try to SSH. We'll see like whether our private EC2 instance is pingable from our public instance. So I will copy my private IP address here. You can see like our private EC2 instance doesn't have a public IP address. So I will ping this instance from my public instance. So you can see it is able to set that bridge. But if I do it through my command line, through my Windows, I won't be able to ping that. We will see it how. See, so I'm able to ping it through my public instance, but I am not able to ping it through my Windows instance, since we have configured the traffic for that private instance to come only from this public instance. So now I will close this loop. Now what we'll do, we will create one, we'll SSH into our private instance and see whether it has internet access or not. So what we will do, we will first create then this method is used to log in into your private instance. So I have to create one key file, sudo nano key.pm. So in this you have to copy and paste the PM version of your key. I already have it open in my notepad, so I'm just going to copy and paste it. I'm going to control save. I'm going to save it. Now we have to SSH. Now SSH ec2 dash user @ it differs on like ec2 user is our username for that instance. Now what we have to do, I have to copy this private IP and to paste it in here, to give -i and that key file that I have created. It will ask for your permission, say yes. Now you can see I am able to log in into my private instance. I'm not sure whether you will be this font is large or not, but I have created the resolution of this video a bit high, so I guess that won't be a problem for you guys to see this small text. So sorry for that if you are not able to view it. I'll upload it if I find it like smaller one. So you can see like we are now in our private instance. We have routed to our private instance through our public instance. So now what we have to check is whether this private instance has internet access or not. So what I will do, I will try and install MySQL in it. Sorry, so it needs root access. I'll give it a root access. So even though it tries to get to internet access, it won't be able to get the internet access. This is because we are not configured the instance, this private instance, to be able to accessible for the internet. But since this should not be the case, our private instance should be able to communicate with internet, but due to the security restrictions. So what is the way that we should do that? So we come on to this creating a NAT instance. There are two ways that your private instance or private subnet will be able to talk to internet. It is through NAT instance or NAT gateway. So firstly we will see how we can use a NAT instance so that this our private instance will able to get internet access. So for that you have to go and launch a NAT instance. It is just like your EC2 instance. Go to community AMIs, search for NAT, select this select any of the NAT instance types that AMIs that are presented. I will just select this one. I will keep the T2 micro as the same. Now what you have to take care that you have to launch this NAT instance in your public IP. So I'll use my VPC and I will launch it in my public subnet. So whenever your private subnet has to contact through internet, it will go through your public subnet, and whatever I guess other things are fine. Let me check it once. Okay, so add storage, we have to add storage, we have to add tags. We'll name it as my so for this I'll configure my security group, and I will use the same security group that I used for my public instance, that public EC2 instance that I have created, so that we'll be able to access that. It will give me a warning. Don't worry about warning. Launch, I will use the same existing key pair to go and launch my instance. So we will wait till this NAT instance gets configured. Now you guys can see that my NAT instance is up. So one thing that you have to do in here, like our NAT instance should act as a mediator. It should not act as an endpoint. So for that you'll understand it how this terminology is fitting. So in that you have to go to your networking and for the NAT instance, and you have to click on this change source and destination check, and you have to disable that check, so it won't act as an endpoint for your communication between your internet and your private subnet. Private subnet. Now what you have to do now, you have to go to your VPC, now in my VPC I have to give that I have to configure, I have to route my NAT instance via private instance. So by default my private instance lies in this main route table. So for that I have to add this private subnet to access internet through this NAT gateway. So I will edit the main root table, and this is for private subnet. So I will go here, I will add allow internet traffic from all sources, and once I will click here, it will give me my NAT gateway. You can see here. So I will select my NAT gateway here, and I will click as save. So the flow was pretty similar. So now, since my main root table has access to internet via this NAT gateway, which is not acting as an endpoint, now we will see whether this private subnet, this that we have used earlier, does it have an access of an internet. So now I will go and try to install MySQL in it. So now you can see that this instance has internet access, and it is downloading the MySQL files from the internet. So this is pretty cool. So we have set up a VPC. It's almost done, but what another way is that we can configure our EC2 instance, VPC instance. So for that, what we will do shortly, we'll go here, we'll go to our EC2 instance. Now after going to that EC2 instance, what I will do is I will terminate that NAT instance and see whether my private instance is able to access the internet or not. So go here, I'll click here, and I'll terminate my NAT instance. This will terminate my NAT instance. I'll give it a permission. Yes, terminate it. Now we will wait for some time to close this or terminate this NAT instance. Now as you can see here, my NAT instance is terminated. Now I will go and see whether I'm able to access internet through my this. It will take time, it will take some time to no, I guess it is trying to download, but you can see that it is not able to download it. So I have terminated my NAT instance, and suddenly my private instance is not able to access my internet. So what is the other way that I can use to make this private subnet talk with internet? So VPC has provision of what they call as NAT gateway. So it is very simple. You just go to your NAT gateways, you create one NAT gateway. See, for the subnet, it will ask like what subnet you want. For the NAT gateway, I will assign it to my public subnet. I will allocate an elastic IP to it, since it is mandatory condition for a NAT gateway. And since NAT gateway is created, we have to let our private subnet know to talk with this NAT gateway to access internet. So the only way possible is by editing the root tables. And like you already know, like our private subnet is associated with our main root table, our main subnet is associated with our new root table, since we have moved it once we have created this our new root table. So since we have to let our private subnet know to access the internet, it should contact to it should contact with new NAT gateway. We will edit the root of our private subnet. So once you see here, the status of this has gone to the black hole. Since we have deleted it NAT instance, it has gone mad. So we will quickly fix this. How we'll fix this? We'll go here, we'll go to edit, go to add, we'll add internet access to it, and once I click here, it will give me this NAT. This is a NAT internet gateway, NAT gateway that we have created. If you click on save, it won't label to save you since it has two destination that has same name, so we have to close this earlier one and we have to click save. Now as per our structured VPC, our private instance or private subnet should be able to access internet via this NAT gateway. So we will see whether it is working or not. So I will just clear my screen and I'll say sudo yum update. So I'm waiting whether it is accessible or not. Is it okay to download? I'll say yes. See, now it's downloading all the updates that we have created. And one thing you should know, once you have created this NAT gateway, you have not configured any of the security groups, and you need not you have not to take care of any restrictions, whether the traffic is coming from your public subnet, and you have to take care your this NAT gateway is not exposed to the world. So whatever that thing that is taken care by the Amazon Web Services for you. So this is our NAT. This is our custom VPC. It is now a full-fledged VPC. You can see here you can keep your main web server or web page in here. You can keep your databases in your private subnet. Your private subnet is able to talk to the internet. So that summarizes our custom VPC through AWS. I hope you guys have liked it. If you guys liked it, then please let me know through your comments. Thank you.